Running water does more to change the landscape than both wind and ice combined. In this podcast, we will look at how water erodes the land, transports the resulting sediment called alluvium, and deposits the sediment. One way in which water erodes the land is by hydraulic action. Now, you've felt hydraulic action of the water when you take a shower, the water blasting away the dirt and the lather. Of course, a good-sized waterfall can blast away a lot more than some suds. Under every major waterfall is a plunge pool, excavated by the power of hydraulic action. Water by itself is not a terribly effective agent of erosion, unless, of course, it contains this. Water that is carrying sediment can really wear away the bedrock by the process of abrasion, also known as corrosion. You probably recognize these pebbles as having been abraded by water, for they're worn smooth. In this picture, we're looking down at Fossil Falls, a waterfall that no longer has any water. As cobbles fell into small holes at the bottom of the waterfall, they were swirled around by the water, and the abrasion caused the holes to get larger and larger. Even if one cobble wore away in the process, another would be likely to fall in and continue the abrasion. These are classic potholes. Another way in which water erodes the bedrock is by dissolution or dissolving. Some rocks are soluble. Limestone is a great example. Limestone is made of calcium carbonate. When calcium carbonate reacts with water, especially if the water contains dissolved CO2, making carbonic acid, bicarbonate ions are formed. The bicarbonate ions are carried away by the water in the form of calcium ions and carbonate ions. I don't have a good picture to show of this happening because dissolved ions are not visible in water. In summary, the three major ways in which running water erodes bedrock is hydraulic action, abrasion, and dissolution. Which is the most effective? Yes, abrasion. As running water erodes the bedrock, it changes the landscape and its own stream valley. The three kinds of landscape erosion are downcutting, making the stream valley deeper, headward erosion, eroding the stream channel and its features further and further upstream, and lateral erosion, making the stream valley wider by the action of the stream's meanders. Now, the Colorado River began at the top of what is now the Colorado Plateau and has eroded the canyon to more than a mile deep, simply by downcutting, eroding the rock directly under the water. If it only cuts straight down, then why is the Grand Canyon over 10 miles wide? In Paria Canyon, a classic slot canyon, the walls are composed of vertical sandstone. That's because sandstone is a very strong rock that does not easily succumb to mass wasting. Most canyon walls are not so strong, they collapse in landslides. The debris of the landslide is then carried away by the water, leaving the stream valley wider. Now here's the lower Mississippi River, meandering across its floodplain. There is no erosion of bedrock going on here, just a rearrangement of alluvium. However, in this example, a meandering river has encountered the edge of the floodplain and is against the bedrock of the valley. The outside of the meander, where the water is flowing the fastest, is cutting into the bedrock, making what we call a cut bank. Here's another example of a cut bank, the bedrock on the side of a meandering river. Often these cut banks are called river bluffs. This erosion by the outside of meanders will make the stream valley wider. This is called lateral erosion. Headward erosion means that the land is eroded in the direction of the headwaters, where the stream begins. Now that's a little counterintuitive, since it's in the opposite direction from stream flow. I'll start with an example that should be easy to understand. Many waterfalls are the result of a hard rock layer capping a softer rock. Over time, the soft rock is worn away, leaving the cap rock above unsupported. Eventually, however, the undercut cap rock will crack and fall, leaving the waterfall further upstream than it was before. Headward erosion. Here's a stream. Well, actually it's more of a wash, a dry stream bed, but during times of rain, its headwaters are eroding into the steep edge of a plateau. Here it is viewed from above. Well, what will happen over time? More rainfall and more erosion. What gets eroded most? Well, the steep headwaters, of course. The steepness increases the velocity of the water, which gives it a greater ability to erode. So not only will this stream erode deeper into that plateau, but eventually the tributaries of the stream will start at a higher elevation in that eroded landscape. The tributaries have gotten longer in a headward direction. Headward erosion. Now let's take a look at how the river transports the sediments that it eroded from the landscape. The ions, such as salts or carbonates, are carried away in solution. They're part of the river's dissolved load. The silt and clay are so small that they're held suspended by the water's movement, so they are part of the suspended load. The suspended load is what makes the water look muddy. The sand is too large to stay suspended, so it tends to jump and skip along in a motion we call saltation. Pebbles, cobbles, and even boulders are rolled and dragged downstream by the force of the water. They are all part of the bed load. Of the three methods of transport, which usually accounts for the most sediment moved? The suspended load. The Mississippi River transports 1.8 tons of silt and clay to its delta every day. That would be up to 300 million tons of mud in 1 year. To imagine that, just think of it filling up 11 million dump trucks. You can even see a plume of mud emanating from the mouth of the Mississippi as seen from space. Let's take a look at the Mississippi Delta. Deltas are depositional features that result when the river slows down as it enters a body of water, such as the ocean, a lake, or even another river. The Mississippi Delta builds up levees along its channels, creating a birdfoot delta that extends far into the Gulf of Mexico. A more classic shaped delta would be the triangular Nile Delta. It's no coincidence that our symbol delta has the triangular shape of the Nile Delta. As a river slows down, entering a body of water, the sand and coarser material moves along the top of the delta, creating the horizontal topset beds, until it gets to the end and falls down, creating the angled foreset beds. When the slope decreases, rivers will deposit sediments that they've been transporting. This can result in sandbars or gravel bars. Remember how the outside of the meander has faster flowing water, so it erodes a cut bank? Well, the inside of the meander has slower moving water, so it deposits sediment. The resulting deposit is called a point bar. You can see a few here. And here's a close-up of a point bar. The picture was taken while standing on the cut bank. This point bar will eventually become part of the Baker River floodplain. A floodplain is the flat land on either side of a stream channel. It is composed of alluvium deposited in meanders and also during floods. In deserts, most rivers are ephemeral. During a flash flood, water will bring sediment quickly down the front of the mountain. But when it reaches the basin floor, the water slows down and deposits its alluvium. The result looks a bit like a delta, and is called an alluvial fan, for the fact that it has a fan shape. All rivers erode the land, transport and deposit sediment. However, different parts of the same river will carry on these different tasks. The steep headwaters are where most of the erosion has taken place, especially downcutting. The main trunk of the river transports the sediment, with small amounts of erosion and deposition going on. And finally, the mouth of the river is all about deposition. My last slide is simply a summary of the major points of this podcast. I hope you found it useful. Have a good day.